for this section, we're going to give your brain a break. And we're going to talk about asymptotes. Why won't my pen work? Forget it. All right. Hang on. No, that didn't work either. Great day. Dadgummit. All right, let's try this. Hey, look. All right. Asymptotes. Okay, asymptotes. So asymptotes are imaginary lines that guide your graph. Okay, we've got vertical asymptotes, which will always take the form of x equals some number. And these are untouchable. It is where your denominator equals 0 if you have one. Horizontal asymptotes will always take the form y equals a number. So remember, for vertical asymptotes, a vertical line slices through the x-axis. So if this were x equals 2, it says x, or I slice through the x-axis at 2. And all it means is every x coordinate you've got is a 2. So the 0.20 is on here, the 0.21 is on here, the 0.22 is on here, 2,000,000 is on there. So all of your x's are 2's. Horizontal asymptote means that it slices through the y-axis. Okay, so it slices through the y-axis at whatever. And this is going to be a comparison. If your numerator has a smaller degree than your denominator. So if you have a small over a big, you stop the world and say y equals 0, unless you have multiple terms, which we'll do in a second. Okay, if you have a same over same, then y is going to equal the ratio of your lead coefficients. Okay, y equals the ratio of your lead coefficients. You can also have oblique, which is the same thing as slant, which is the same thing as diagonal. Asymptotes, and that's if your numerator is 1 bigger than your denominator. And then you would have to do long division and all that kind of stuff and find the equation of a line. So it would be y equals mx plus b. But we're not going to do that because your brain is already stretched. All right, so let me give you an example. If I have the function, and I've got y equals 1 over x. Okay, so first of all, I want to know about my vertical asymptotes. Vertical asymptotes are untouchable. And you can find them by grabbing your denominator after you reduce and simplify. Okay, grab your denominator, set it equal to 0, and solve. Well, this is already solved. So you have a vertical asymptote at x equals 0. So what does that mean? I have a graph. 1 over x looks like this. Okay, he looks like this. So what you just discovered is that you have a vertical asymptote that slices through the x-axis at 0 and it guides your graph. So what does it mean by guide your graph? The closer I get to an x value of 0, the closer this is going to hug up next to it but never touch it. Okay, the closer I get to an x value of 0, the closer this is going to hug up next to the axis and never touch it. And remember, the equation of that axis is x equals 0. All right, so let's try another one. I have, what about horizontal asymptotes? Okay, it cannot be both horizontal and oblique or slant. So you don't have to worry. It's either one or the other, and I did not give you any slant or oblique. Okay, so horizontal, well, my setup is I've got to compare my numerator and my denominator. So remember, I've got a 1, and I can always put in x to the 0, because x to the 0 power is 1. And this is x to the first. So all I did was rewrite this. Okay, 1 times x to the 0, which is 1, is 1. And then x to the first, we're always too lazy to write the 1. So my numerator has a degree of 0, and my denominator has a degree of 1. So I've got a small over a big. So you immediately stop the world and you say, I have a horizontal asymptote at y equals 0. So come back up here. That means you have a horizontal line slicing through the y-axis at 0 that's guiding your graph. So as this comes down this direction, it's going to hover just on top of the axis and never touch. As this comes up this direction, it's going to hover just under the axis and never touch. So those are your two examples for that. Also remember, please, that your equations are actually equations of lines. If you just put 0, it's wrong. You have to tell me the equation of a line. So the last one, I've got to use a different example. So let's try y equals, and then have 4x to the third minus 4x squared plus 9 over 7x to the third plus 16. Okay, I want to know what my, and I'm not going to give you a vertical one. Okay, I'm just not, because it's scary. But I want to know if you've got a horizontal asymptote. So how do I set that up? I know it's a y equals. I also know that I need to compare my exponents. So up here I had a smaller degree over a larger degree. So a small over a big means you stop the world and scream y equals 0. Well, here, remember, I don't care what comes after it as long as it's in descending order. So I have an x to the third over an x to the third, which means my asymptote is the ratio of my lead coefficients. So you have a horizontal asymptote at y equals 4/7. Y equals 4/7. Okay, so that's all we're doing in this section, is we're just going to bedoodle on through and use pictures and use equations to figure out the asymptotes.